Now we have our Earth and the Sun rotating. Let's assign texture to the Sun and to the Earth. We press Tab and start typing UV Quick Shade. UV Quick Shade. And place the node between the Sphere node and the Earth rotation node. Here, by default, we have UV gray picture. You can see the picture. Let's assign our texture. For this we press this icon, open floating file chooser. And here we have Earth for Houdini JPEG file on the desktop. Press accept. That's our texture here. You can download a similar texture from the internet. We see that it's a little bit messy, so we need UV project node here. We press tab and start typing UV project and place the node between the sphere node and the UV quick shade node. It's still messy because our texture is a little bit distorted. To eliminate that, we need to choose polar in the projection type options. Now we have a more or less acceptable result. The texture is assigned and it's rotating, all right. Let's assign a texture to the sun. We go from the geometric context up to the objects level. Here we have to double click on the sun node. Again, we add UV quick shade. Press tab and start typing QS UV quick shade. Okay, by default we have the same picture. So we click on the file chooser here. We can download this texture from this site. Just Google sun textures map from NASA solar full dome image. This is the link. Now I go to the folder with textures. This one is here, the sun texture. Okay, again we need to add the UV project node. So we press tab and start typing UV project. Here in UV project, in the projection options, we choose polar again. Now let's assign textures in Maya. So we select our Earth and right click to assign Lambert. And here we have color. We just press the color icon and select File, and in the image name we go to the folder with textures. This is our folder with the earth textures. So we press 6 or 5. 6 and 5 in Maya just display the texture or without a texture. Six with a texture map and 5 without a texture map. 6 and 5 are the hotkeys. Here we have our textures. It's more or less okay. So we will not change anything here, probably. I think it should be fine. If we select UV editor here, we'll see our textures there. Okay, for the sun, double click and go to favorite material and assign Lambert. Go to color, then file, image name, and go to your folder and select your texture. So our sun is here, the sun texture is here, the sun texture is here. Now we have the rotating earth and the sun. To see our textures better, we go to shading options and just uncheck wireframe unshaded. So here we have our textures on the rotating objects in Maya and Houdini. Now the next stage is the creation of the rotating moon. In Houdini we first create an attribute wrangle node. We press tab and start typing AW. In this attribute wrangle node we write our first line. Matrix rem equals ident, and then parenthesis, and then we end the line with a semicolon. This line of the expression means that we create 3 by 3 matrix, and we call this matrix M, and ident is a vex function that returns the identity matrix for the given matrix type. Okay. Next we write vector axis, then equals CHV, that means channel. We call this channel axis, and this vector will rotate this matrix around the given axis. And we need to specify the number, so like we say 0, 1, 0. 1 means that our rotation will be realized around y-axis. Okay. Then we write float amount equals attribute time, and we divide it, for example, by 4. Why set it to time? Because our object will be orbiting during the whole time period of our timeline. We might of course specify that in radians. And by creating this channel, we might call this channel angle. We might set a specific angle in radians. Okay, but in our case we just write the attribute time. Then we write our function rotate, and the parenthesis. We write m aromatics, then amount of the rotation. And the amount of the rotation will be our time attribute. And then we specify our axis, and our axis is y. We specify our axis, and our axis is y. And then when we write p multiply equals matrix, it means that we multiply each point by this new matrix to rotate the object. Each point of the object will be rotating around the y-axis. Okay, when we have the sun and the earth rotating, the sun is rotating, the earth is rotating, orbiting the sun, we just press tab and start typing sphere and choose the polygon sphere. Then we press tab and start typing merge. Select the merge node and move it to place between two attribute triangle nodes. Okay, then we connect our merge node with the sphere node. Let's play. If we choose our wireframe and shade it and select our sphere, we see that our sphere, our newly created sphere, is inside the sun. So what we need to do, we need to select our sphere and change the center. Then select our node, our attribute triangle, and when we play, we see that our moon is following the earth, but it's not rotating. Press stop, select our sphere, and probably change our uniform scale. Change our center, making our moon closer to the earth. Now we create a new attribute triangle node. Press tab and start typing attribute triangle. Select the attribute triangle node. We choose attribute triangle node which is responsible for rotation of the earth. So we just select our expression, the whole expression, Ctrl C to copy it, and Ctrl V to paste it into this attribute triangle node. We see that our moon is just changing the scale, but it's not rotating, so what we need to do, we need to activate our expression. by just pressing this tab and changing our axis, the y-axis, to 1, because it should rotate around the y-axis. Now we see that our moon is rotating, orbiting the Earth. And let's just choose flat wire shaded in display geometry smooth shaded options. So we see that it's rotating, okay? Now the next step is to put a texture onto our moon. And now when we have our moon, the sun, the Earth rotating, let's assign a texture to the moon. So we just press tab and start typing UV project and choose it from the list. Then press tab and start typing UV quick shade node. Choose UV quick shade node and place it after UV project node. Okay. So now we go to UV quick shade node and change our default texture map to the moon texture. Let's select our moon. We might increase rows and columns values. Okay, let's hide our sun for the time being. We see that we have our texture, but it's blurred and distorted a little bit when we select UV quick shade node. Well, we might go to the UV project node and to the projection type and change to polar. Still we see this seam. If we go to viewport layout and choose two views side by side and choose UV viewport in the set view, we will see the UV projection map. So what we might do, we might open our texture in Photoshop. We make the selection here and then layer, new layer via copy. Just move here. And then copy this layer. And then go to Edit, Transform, and flip horizontally. Then move the layers. But we still see these seams, so what we might do, we merge our layers. And then select the healing brush tool. And quickly make the seams invisible. More or less. Then we go to save it, export as JPEG. Let's just name it moon. Revise. Revised, okay. Then go to our UV quick shade node and change our texture. Well, still we see some artifacts, but more or less this is acceptable. Let's change our view to single view. For the time being, it's okay. Go to the objects context up, display our sun, go back and display our attribute wrangle node. Now we have our sun, Earth and Moon. Well, we might change the speed of the Earth rotation, so we select our attribute wrangle node here and change these values. We might also change the speed of the Earth rotation. We select this expression in this attribute wrangle node, change it to 2, and the Earth is rotating faster. Well, in Maya we have our sun and the Earth rotating, so we need to add the moon also. If we just, for example, create a sphere, let's move our sphere. Select the Move tool for that. Now we have the moon. Let's scale up the moon a little bit. So let's rename our sphere to moon. Select the moon and then shift select our Earth. Go to Edit, Parent. Now our moon is parented to the Earth, okay? It's rotating. If we just zoom in, we can't see whether it's rotating or not. To see if it's rotating, we might go to the face mode and shift select these faces. Then right click and go to favorite material, Lambert. We might rename it Moon. select the color icon and make it red. Let's see what we have. Just press step forward one frame on the timeline. We see that the moon is not rotating in y-axis. I mean, it's just orbiting the Earth. Here what we might do is to add an expression to the moon, okay? If we select rotate Y, for example, then go to edit expressions and select moon dot rotate. In selected object and attribute, Ctrl C to copy it, Ctrl V to paste it into the expression field. We write moon dot rotate Y for the rotation in the y-axis equals time. We multiply it by 50, for example, to see the rotation better, okay? And end with a semicolon, then press create. Now we go to zoom in and play frame by frame. For that we press step forward one frame button. We don't see our moon rotating on the y-axis. So we multiply the time by 500. And now we see that the red strip we assign the material to is facing towards the Earth. And it's rotating. If we deselect the moon, we might see better that it's rotating. It is rotating around the y-axis, but what we need to do is to control the orbiting of the moon, how fast it orbits the Earth. The moon orbits the Earth, but the speed can't be controlled. We can't change the speed because it is controlled by the expression of the Earth. If we select our translate channel and go to edit expressions and see our Earth expressions, and if we make the Earth rotate faster around the Sun, multiplying it, for example, by 20 in sine and cosine expressions, we multiplied that time by 20, saved it by pressing edit. Now you see that if the Earth is rotating faster, the moon is rotating faster as well. Therefore, we can't control the rotation of the moon. We copy this expression. Select the moon and go to the expressions, edit expressions. paste it and just rename Earth to Moon, then edit to save the expression. Let's go to the wireframe mode. Our moon is too far away from the Earth, so if we make it like 20, maybe even 10, edit. Maybe even 5 and edit, okay? What do we have? Go to the smooth shade all mode. And we see that, for example, if we want to make the rotation of the moon slower, we multiply the time by 50 and edit. Still, we can't control the rotation of the y-axis because of the parenting. If we parent the object, everything will be parented. Like we are parenting rotation, translation, and scale. So if we make, for example, like 5 and edit, still the moon is rotating too fast because it's not controlled by the expression. This expression doesn't regulate the rotation orbiting, okay? It doesn't control the rotation of the y-axis of the moon either. So what do we need to do? We need to make the rotation, the orbiting of the moon slower around the y-axis, okay? We need to find some other way to parent our moon. One way is to do that manually, okay? Let's stop playing. We might comment all the lines and edit. We still see that it's rotating around the Earth because it's controlled by the expression of the Earth. So let's stop playing. We select our Earth and the moon and then unparent so that we might see the moon here. We might make the translation 0. We may hide the sun for the time being. Select our sun, go to displayed, hide selection, or Control H, the hotkeys, okay. Now we have our Earth rotating and our moon rotating. Select the Earth and moon and show only in geometry. And go to add selected nodes to graph. And by clicking this, we might open all the inputs and outputs and have the Earth and the moon together. Now we press tab and start typing mathematics. We select the moon and press add selected nodes to graph. Okay. So we have the moon and we have the Earth. Alright, next open all the inputs and outputs in the Earth and the moon nodes. Okay. Then we add decompose matrix node by pressing tab and typing decompose. If we press 1 or 2 or 3, we open these nodes. By pressing 1, we have only one level, the first level, and then we press 2 and we have the second level. We go deeper, and by pressing 3, we have all the levels open. Now we connect world matrix with matrix input, matrix in, matrix in. Then we select matrix sum and connect with the input matrix in the decompose matrix node. And next we connect only translate. If you want to control only the translation, let's see what we have. Press wireframe. We see that our moon is connected to the Earth, but it's not orbiting the Earth. So what we need to do, we see that our moon's channel are locked. It's not locked, but it's just not available. We can't modify expressions. We can't add expressions. If we select filter and choose by expression and name, then select expression and rename our expression to moon. See if we remove our comments to activate our expression. And then we press edit. The moon size is bigger, so we make it smaller. That's the moon. Okay, we see that the moon is not orbiting the Earth, but the Earth is orbiting the moon, not the moon. Okay. we change our translate y and translate z, multiplying by 200, for example, and then press edit. Let's make 220, for example. So we see that it's parented, but it's not orbiting the Earth. Let's just play by pressing step forward 1 frame. If you make the speed like not 5 but 50, then edit. Just flies away somewhere. We can't manage that, so if you make the moon rotate y, for example, it still doesn't work. What we need to do is to find a way around. First, let's go to node editor and delete these connections. Then we select the moon only, go to edit, group, to create a group. So now we have the group, our group 1. We select the group in outliner, and add selected nodes to graph and press 3 to open it. After that, right-click on Mult Matrix and select Show All Attributes. Then select Decompose Matrix. Right-click and Show All Attributes. Well, now we need to connect world matrix 0 with the matrix in 0. Then we connect matrix sum output with input matrix. Next, we only connect our translate, so it means that only our translation will be parented to the Earth. The mult matrix node multiplies together 2 or more matrices to create a new matrix, and the decompose matrix node takes data and extrapolates out translation, rotation, and scale. We see that we have only translation, the output translation parented. That's why we can control separately the rotation and its orbiting. So now we have the Earth orbiting the Sun and rotating around its y-axis, and the Sun rotating around its y-axis, and the Moon orbiting the Earth and rotating around its y-axis. And everything can be controlled separately. If we change and then select Translate and go to Edit Expressions we might change the rotation of the y-axis. So we have the pretty high rotation because it's approximately 1 year of the orbiting of the Earth. So the Earth is revolving almost 20,000. If you make like, let's see, 200 and edit, we see that the rotation is very slow, okay? So it's rotating. Alright, and then if we again select by expression name, select by expression name the Earth. If we change, for example, the time here, the time, just multiply, or we might even divide the time by 8, okay, and then edit. It's orbiting very slowly, okay, so let's see, make like 2 and then edit. It's very slow, but we have the full control of the orbiting and rotating. So let's just go back and then add 0 and 5 and edit, okay. And the moon, if you select the moon and change the time, for example, if we multiply or without multiplying, okay, and edit, just very slow, hardly visible. If you just change and multiply by 20 and edit, we see that it's orbiting too fast, okay. So we just leave 5 as it was before. And the Sun, of course, is revolving around the y-axis, and the Moon, if we change if we go to the Moon, we can hardly see the texture, okay, because it's very light, okay. However, we might just select the faces again. If we select the faces and change the time rotation to make it 1000, okay, we see that it's orbiting, okay, it's visible. By looking at the selected faces, we see that it's orbiting, okay? Alright, let's leave 200 as it was previously. That's the rotation and orbiting of our objects in Maya.